In this video, we'll try to understand the steps in first and second generation panel data econometrics. And the key here to use first and second generation panel data econometrics is basically having a very large T, that's number of time periods, and moderate to large number of time of cross sections, that is n, which could be firms, which could be countries. In most instances, in my own research, I use country level data. So before we start talking about the steps in first and second generation panel data econometrics, we need to understand what they actually are. So first generation panel data econometrics is basically uh, panel data analysis that do not account for cross-sectional dependence. And the cross-sectional dependence, mathematically or statistically, is when the expected value of the error term in one country and the expected value of the error term in another country is not equals to zero. If it is equals to zero, there is no cross-sectional dependence. If it is not equals to zero, there is a cross-sectional dependence. And a key cause of cross-sectional dependence can be shocks, shocks that affect countries across across board. For instance, we could say the global financial crisis uh, actually had effects and caused cross-sectional dependence because it affected the error term in a given country, which also affected the error term in another country. So that being said, the expected value of the error term in maybe Nigeria and the expected value of the error term in South Africa do not are not now equals to zero as they should be. So when two error terms in two given countries are not equals to zero, there's cross-sectional dependence. And for first generation panel data econometrics, they do not account for cross-sectional dependence. So in instances when there are no cross-sectional dependence, we can easily estimate an OLS, a fully modified OLS, a dynamic OLS, a pooled main group dynamic phase effect. And based on the unit rate process, we could use the leveling true, that's the LLC, IPS, ADF Fisher, PP Fisher, and for co-integration, we could easily use the Cal, Pedroni, and the Westerlund co-integration test. So within this framework, they do not account for cross-sectional dependence. Then for second generation, when the expected value of the error term, the expected value of the error term in country I and country J is not equal to zero. So we can no longer use first generation procedures. So what we do, or the most common techniques in panel data analysis, becomes the augmented mean group, the common correlated effect mean group, the CSARDL model. And for unit roots, it is always best to use the CADF and the CIPS panel unit root test. And for co-integration tests, we could also easily use the Westerlund 2007 test for co-integration. I think the command in Stata is the XT West. So when to use what? Panel data. First thing you need to do, particularly when you have moderate to large N and you have a large N, sorry, and you have a large T, is that you do test for cross-sectional dependence. If it's a yes, you use second generation. If it's a no, you use first generation. Now, for first generation, the procedure is to first of all account test for unit root tests with LLC, IPS, ADA Fisher, PP Fisher. If you have a mix of I0s and I1s, you can easily do the pooled main group, the main group, and dynamic fixed effects. If your variables are I1 stationary, you test for co-integration. If there's co-integration, so you test for co-integration using the Cal, Pedroni, and Westerlund. But if there's no co-integration, most literature says that we could use the panel VAR model. Now, when there's co-integration, what do you do? After testing for co-integration with the Cal and Pedroni and Westerlund, what we now do is to estimate our models using dynamic fixed effect, using the dynamic OLS and fully modified OLS. Research literature have also said that both the dynamic OLS and the fully modified OLS are able to account for indigeneity. So these two estimation techniques are actually robust. They are good long-run estimation procedures. Now, for second generation, as I said earlier, we do panel unitary test using the CIPS or the CADF. If you have a mix, if your variables are a mix of I0s and I1s, you do the cross-sectional dependence ARDM model, also called the CSARDM model. If there is, uh, if your variables are I1 stationary, you test for co-integration using the Westerlund second generation test. No co-integration, some literature says we could use VAR. And yeah, so when you test for co-integration and there's co-integration, we can now use the augmented mean group and the CC common correlated effect mean group. So both estimation techniques account for their long-run estimation techniques, and they account for cross-sectional dependence. And the CCEMG, if I can remember correctly, the CCEMG, sorry, where yeah, so the CCEMG also accounts for indigeneity, which the augmented mean group do not account for. So that is more like it. Then we also have what we call a third generation panel data econometrics. Now, this accounts for structural breaks. To the best of my knowledge, this is still in development, and but there is a panel unitary test that accounts for cross-sectional dependence and structural breaks. With the command, I think the command on state is the XTB unitary test. Thank you very much.